Alright, so I think I'm recording. Let's solve this equation. It's an exponential equation. It's an exponential equation that doesn't require me to use any logarithms, which are the inverse of exponential functions. I can rewrite each side with the same base. So let's leave the left-hand side alone for a second because maybe a student wouldn't see what to do with that quite yet. But on the right-hand side, the 16 has promised that we can rewrite the number 16 as either 4 squared or 2 to the 4th power. Since I have a 2 in this denominator, the 2 to the 4th power shows promise. Okay, that's the number 16, and this 16 is being raised to an exponent of x squared minus 1. So on the left-hand side, if I have 1/2 and 1 minus x, then a power to a power, you multiply the exponents. So this 4 gets distributed over this subtraction. You multiply both terms by 4. Alright, so right now, on the left-hand side, I have a 1/2. But on the right-hand side, the base is 2. If I just had a way of taking the reciprocal of this 1/2 and making this 2 over 1, hey, 2 over 1 is 2, and I'd have the same base. Well, I can't just come in and flip it, but I can flip it if I change the sign of the exponent. A negative exponent never makes your answer negative. Remember that the property of exponents, that b to the negative n is just 1 over b to the positive n. So that base changes location within a fraction. Alright, so let's write this with a base of 2. Let's distribute this negative sign. I'm just going to change the order of that subtraction, and you can see that the negative x becomes positive x, and then it's x minus 1. Alright, so these numbers are the same, and the bases are the same. And since this exponential function is a 1-to-1 function, then I can set the exponents equal to each other. Alright, so we have a lot of experience in solving quadratic equations. We want to get it in standard form, so we want to get this guy equal to 0. So we've got 4x squared. This 1x, it changes sides to become negative 1x, and the negative 1, it changes side to be, I add 1 to each side, and negative 4 plus 1 is a negative 3. And so here again is an example of the when the x method is kind of powerful, because with this composite number 4, you have multiple combinations of how to get 4x squared. You've got 1x times 4x, 2x times 2x, or negative 1x times negative 4x, negative 2x times negative 2x. You have these different combinations. Well, your Algebra 1 team, when you took Algebra 1, decided to teach you a method that they referred to as the X method that will help you when you can factor polynomials, a quadratic function. If you can't factor it, the quadratic formula will always work, and so will completing the square. But let's see if we can factor this. The middle term is negative 1x. The first term times the last term is negative 12x squared. So here's the process that they refer to as trial and error. We need to come up with two numbers that when multiplied together give us the top number, but when added give us the bottom number. So with a little bit of playing around with the numbers, negative 4 and positive 3 do the trick, because the negative 4 times positive 3 is negative 12, but when you add those together, you get negative 1. So let's come down and make a table. And in our table, Along one diagonal is our first term and last term of the original quadratic equation from standard form, and the other is diagonal will use the numbers that we found in our x, and these diagonals have entries that are interchangeable. Alright, so if we look across the bottom here, that what they have in common is a 3, and when we look here vertically, what they have in common is the negative sign, so we'll write -1. Horizontally here, what these two terms have in common is a 4x, and what these have in common is just the variable x. So if you multiply these outside entries, you can see that we get the inside of the table. So we can use this now to factor this to 4x plus 3 and x minus 1. So now by that zero coefficient theorem, we can split this one equation into two equations. Either 4x plus 3 is representing the number 0, or x minus 1 is representing the number 0. So on the left, that's a two-step equation to solve for x. You subtract 3 and divide by 4, and you'll get -3/4. Over here, it's a one-step equation. You just add 1 to each side. Since the exponential functions have a domain of all real numbers, I don't have to worry about extraneous solutions. So if I haven't made a mistake in my solution to get to this point, these two are my final answer. Alright, so I hope that helps, and I'll talk to you later.